Transmission Control Protocol is a connection-oriented service. It plays a major role in transport layer to provide a reliable data transfer and to control the flow of the mechanism. Key features of the TCP are sequence number. So it assigning a unique sequence number to each byte of data that helps in reassembling at the receiver side. Then it using acknowledgement numbers, which indicates the next expected sequence number. The window size that specifies the amount of data the receiver has been acknowledged. The key issues involved in the TCP are TCP service model, TCP protocol, TCP segment header, the connection management, transmission policy, congestion control, and TCP timer management. The service model, it is obtained by having both the sender and receiver create endpoints called sockets. TCP protocol that includes a sliding window mechanism and a timer that helps to prevent the loss of data, and it makes the retransmission in a quick manner. Then it involving the structure and field of TCP packet headers. Then connection management. So for connection management, they are using a three-way handshake protocol and the transmission policy that helps in governing the data transmission and the flow control mechanism. So for congestion control and to control the network traffic, they are implementing leaky bucket and token ring based algorithms. Then the timer management has been implemented with the timeout mechanism and the strategies of retransmission policy. The service model. So the both sender and the receiver has a separate create endpoints called sockets. So it contains the IP address of the host that we call as port. So it is involving with the full duplex connection. So both the sender and receiver can able to communicate with each other at the same time. Then in terms of a byte stream or chunks, the data has been transmitted. So the 8 bits collectively has been represented as 1 byte. So a simple example is 512 bytes of data separated into 4 chunks at the sender side, and by chunk it has been transmitted over the path. Multiple connection has been happened at the same time at the socket. So the port 21 has been used for establish a connection. The file transfer protocol is a simple example, and the telnet has been useful for port 23. It helps to establish a remote login session. Protocol, as we already mentioned, it involves with the sliding window protocol. So at the sender side, we are having one timer. After the data has been transmitted, it has to wait for some amount of time. When the timer goes off and the acknowledgement is not yet received, means the sender retransmit the segment again. TCP segment header, it involves with the source port and destination port. It collectively has a 32 bits. Then it involves with the sequence number and acknowledgement number. It has a separate control flags with a window size that is of 16 bits. Then it includes a error detection mechanism as a checksum. Then urgent pointer has been included. TCP segment header. So source port 16 bits, destination port 16 bits. Source port, it is a port number for a sending process, and this one for receiving process. The sequence number that helps in indicate the sequence of the first byte of data in the segment. Then the acknowledgement number. If the acknowledgement flag has been indicated by 1, means it contains the next expected byte from the sender side. Then the header length. So it is specifying the length of the TCP header in terms of 32 bits. Then the reserved field has been used in future. It is initially set to 0. Then it has a separate 6 control flags or control bits. Window size that helps in advertising how many bytes the receiver is willing to accept. It helps in flow control mechanism. Then the checksum, the error control mechanism. It is useful for checking the error with the help of header and data. Then the urgent points. If the urgent flag is set to 1, means the point is to urgent the data in the segment. Then for additional features, this options padding has been used. Then the data payload. It is actual application carried by the TCP. These 6 are the control flags. Urge. If the urge is set, means the data is processed very urgently. Acknowledgement. If the acknowledgement is set to 0, the packet does not contain any acknowledgement. If it is set to 1, means that is representing the acknowledgement. Then RST, it helps to restart the connection. This PH is representing in pushing the data directly to the receiver without buffering it. Synchronization, If the synchronization is set, means the device wants to establish a secure connection. FIN that represents to terminate the connection. Three-way handshake protocol to establish a connection. So whenever we are going to establish a connection and to make them in a secure manner, we have to implement this three-way handshake protocol. So initially the synchronization, client side a synchronization segment is to make it to the server with the client's initial sequence number. Then at the server side, it responds with a synchronization with the acknowledgement that acknowledges the client's synchronization and indicates the server sequence number. Then ACK, now the client sends the acknowledgement to start the data transmission. For connection management and termination, so this is that procedure. So here in this, initially the client wants to close the connection, it sends a FIN packet. So from the server side, here two operations are done. So first the server receive the FIN and acknowledges it. If the acknowledgement flag is equal to 1 means it has to transmit with the client sequence plus 1. Okay, so at this point the connection is half closed, and to make the connection fully closed, so when the server is also ready to terminate, it sends its own FIN. Okay, third stage, the client also acknowledging the servers closing the connection, so it acknowledges with the flag 1. The main TCP features it is helpful in full duplex connection, so the data has been transmitted simultaneously in both direction, and a many to one and one to many application is there for TCP through the port numbers. Then it involves with a separate checksum, so it is having a error detection and correction mechanism. Fourth one is data transfer in a sequence order. So if any data is lost, means it helps to reconstruct the data, that helps in guaranteeing data delivery in a particular order. The real world TCP examples that we are using are browsing the web. So it ensures the reliable data of the web sources. Then email. Okay, so for email we are using that concept of SMTP and file transferring. Then the TCP uses a error-free file transfer. Thank you for watching the video.